Our closest celestial neighbor, the Moon, has captivated humanity for millennia. We have walked upon its dusty surface, planted flags, and brought back samples of its ancient rocks. But now, our relationship with the Moon is poised to enter an entirely new phase. We are looking at it not just with wonder, but with an eye for the resources it holds. Imagine a future where the Moon is an active partner in our civilization's progress. This is no longer science fiction. It is the dawn of a new era in space utilization. Companies and nations are considering the vast, untapped potential lying dormant on the lunar surface. This quest is driven by the search for unique materials, elements rare on Earth but potentially abundant on the Moon. The Moon might just hold the key to a more sustainable and technologically advanced human society. The journey to make lunar mining a reality is just beginning. So what is this helium-3 and why is it causing such a stir? It's a light, non-radioactive isotope of helium. On Earth, helium-3 is incredibly scarce, but the Moon holds millions of tons of this precious isotope. The primary allure of helium-3 lies in its incredible potential for clean energy generation. Scientists believe it could be a perfect fuel for nuclear fusion reactors. Fusion with helium-3 produces a massive amount of energy, but, crucially, its byproducts are not radioactive. Imagine power plants that generate vast amounts of electricity with minimal environmental impact. That's the promise of helium-3 fusion. The ability to harvest helium-3 from the lunar surface could accelerate the development of fusion power, providing a clean energy solution for generations to come. Enter Interlune, a Seattle-based startup with a bold vision. This pioneering company is actively developing the technology to make helium-3 extraction a reality. Interlune's mission is clear: to mine the Moon for this rare isotope and bring it back to Earth. At the heart of Interlune's project is a sophisticated piece of machinery, a prototype excavator. This machine is designed to operate in the harsh lunar environment. It can dig up to 10 feet into the lunar soil and process up to 110 tons of lunar soil every hour. Interlune plans to process the helium-3 directly on the Moon, reducing the mass that needs to be launched from the Moon. Interlune is working with Vermeer, a company renowned for its expertise in industrial excavation equipment. The prototype excavator is currently undergoing extensive testing here on Earth. Interlune is meticulously preparing for a future where lunar resources power terrestrial progress. Interlune isn't just launching a single mission. They have a carefully structured three-phase plan to achieve their goal of harvesting lunar helium-3. The first phase, Crescent Moon, focuses on reconnaissance using a hyperspectral camera to scan the lunar surface. This technology will help identify areas rich in helium-3. The second phase, Prospect Moon, involves deploying a lander to one of these sites. This lander will carry instruments for on-site measurements and test early extraction technology. The final phase, Harvest Moon, will see the deployment of the complete extraction and processing system. The goal is to continuously mine the lunar regolith, refine the helium-3 on site, and transport the gas back to Earth. This three-step approach, identify, verify, and then extract, is a logical pathway to achieving such an ambitious goal. Each phase builds upon the last, mitigating risks and increasing the chances of success. Interlune's phased plan reflects a commitment to establishing a sustainable and efficient operation. Embarking on a mission to mine the Moon is an extraordinary undertaking, filled with immense challenges. Designing equipment that can withstand the harsh lunar environment is a monumental engineering task. Beyond the technical complexities, Interlune must navigate a complex web of space exploration regulations and international space law. Securing the significant investment required for such a long-term, high-risk venture also presents a substantial challenge. Despite these obstacles, the potential global impact of successfully mining helium-3 is truly staggering. It could position the United States as a leader in space resource utilization. A reliable supply of helium-3 could accelerate the development of clean fusion energy, offering a path away from fossil fuels. Ventures like Interlune's have garnered backing from governmental bodies, such as the US Department of Energy. The estimated cost of helium-3 underscores its immense value and the economic incentives driving its pursuit. The promise of a cleaner, more technologically advanced future provides a powerful impetus to reach for the stars.